Hello. In this video, we are going to see about DC generator. The generator is a dynamic machine in which the mechanical energy is converted into electrical energy. It operates on the principle based on the Faraday's law of electromagnetic induction. The EMF generated is to be classified as dynamically induced EMF. The basic requirements for the dynamically induced EMF to exist are the following: a steady magnetic field, a conductor capable of carrying current, the conductor to move in the magnetic field. The working principle of a DC generator is illustrated in figure 6.1. It shows a steady magnetic field is produced by the pole pieces of the magnet north and south. A single turn coil ABCD is placed in the field produced between the pole pieces. The coil is rotated by the means of a prime mover. Thus, as per Faraday's law, an EMF is induced in such a coil. Such an EMF is basically alternating. The bidirectional induced EMF is made the unidirectional using the commutator. The figure 6.2 illustrates the use of a commutator. Construction. For this satisfactory operation of a DC generator, it should consist a stator and a rotator. The stator accommodates the yoke, the main field system and the brushes. The rotator has the same armature and the commutator and its main parts. Figure 6.3 shows these parts. Each of these parts is described as follows. Yoke or frame. It is the outermost solid metal part of the machine. It forms the part of the magnetic circuit and protects all the inner parts from mechanical damage. Field system. It consists of the main field poles and field winding. The field poles are made of laminations of suitable magnetic material. Such a magnetic material has a very high relative permeability and a very low hysteresis loss. The pole face is in the form of a horseshoe so that the uniform flux distribution is obtained in the air gap between the poles and the rotating part. The field winding is placed over each pole and these are connected in series. Again, the field winding is arranged on the different poles that when a direct current is passed through the winding, the poles get magnetized to north and south polarities alternatively. Thus, the field system is responsible for producing the required flowing flux in the air gap. Brushes. A set of brushes made of carbon or graphite are fixed such as they will always be in gentle touch with the revolving armature. The generator is connected to the external circuits by the means of these brushes. Thus, the brushes are used to tap the generated electrical energy of the rotating part of the generator. Armature. The armature of the DC generator is in the form of a laminated slotted drums. Slots are provided over the entire periphery of the armature. Commutator. The commutator is similar shape to the armature, but it has less diameter than that of the armature. Required number of segments are provided over the complete periphery of the commutator. There is an electrical insulation between every pair of segments. A minimum 2 of conductors are connected to each segment, but at the same time, the 2 conductors making a single coil are connected to different commutator segments. The brushes are so placed that they are always keeping in to touch with the revolving commutator segments. DC motor. Principle. Whenever a current carrying conductor is kept in a stationary magnetic field, an electromagnetic force is produced. This force is exerted on a conductor and hence conductor is moved away from the field. This principle is used in DC motors. Construction. The construction of a DC motor is exactly similar to that of DC generators. The salient parts of a DC motor are yoke, frame and main field system, brushes, armatures and commutator. Working. In both DC motor and both armature fields of windings are connected to a DC supply. Thus, we have a current carrying armature conductors placed in stationary magnetic fields. Due to electromagnetic torque on the armature conductors, the armature starts revolving. Thus, electrical energy is converted into mechanical energy in an armature. When the armature is in motion, we have a revolving conductors in a stationary magnetic field. As per Faraday's law of electromagnetic induction, an EMF is induced in the armature conductors as per Lenz's law. This induced EMF opposes the voltage applied to the armature. Hence, it is called the counter or back EMF. There also occurs a potential drop in the armature circuit due to its resistance. Thus, the applied voltage has to overcome the back EMF in addition to supplying the armature circuit drop and producing the necessary torque for the continuous rotation of the armature. Thank you.